Sustainability is about building solutions to a brighter, better tomorrow for us and our loved ones. To that end, we've brought these solutions closer and closer to our hearts and our homes. From the way we throw, to the things we buy, and even how we get our electricity. Many have opted to install solar panels right on their roofs to generate cleaner energy and save some money while they're at it. Some have brought wind turbines onto and around their homes to help them generate in a similar yet vastly different way. One harnesses the sun, while the other harnesses the wind. But just as we use a plethora of ways to generate our renewable energy through our country, why shouldn't we do the same on our houses too? At the times when one isn't enough, the other should be given a chance to shine. And to ensure that both help one another, we introduce you to the clutch. When the sun is out, your solar panels work hard to deliver you and your neighbors a steady stream of clean energy. In a sunny country like Malaysia, it's a great way to get all that heat to work for you. Your wind turbines can help generate some energy too, when the wind begins to pick up some speed. But when the rain comes in, you can put your solar panels to rest and let the rain clean off all the dirt and dust to help keep it at optimal efficiency the next time it's in use. This is when the clutch comes into use. The flaps fold out and position itself by each panel. The angle of the roof directs the wind incident to it up towards the wind turbines at a higher velocity. Then, the curvature of the flaps operate to direct the wind even faster past the blades of the wind turbines. The higher wind speeds then help to increase the rate of rotation of the wind turbines, increasing its energy output and overall efficiency at a given wind speed. When the rain stops and the wind slows down, the flaps have done their job and fold into their standby state. By folding in, the height of the flaps decrease, minimizing the amount of shading it casts onto the solar panels below it, letting the solar panels get back to work at generating energy once more. The flaps, when deployed, guides incoming wind through the space between the two wind turbines and out through the narrow gap at the back, increasing the velocity of the wind passing through it and maximizing the energy generated by the turbines. The structure of the clutch utilizes its 8 folding joints around its frame to extend to its operational mode and retract to its standby mode. An additional 2 more joints hinge the directional flaps that aim incoming wind towards the outer wings of the 2 parallel wind turbines. Going from its operational mode to its standby mode, the clutch is able to reduce itself to a third of its original height from its outermost height. The flow simulation was conducted to analyze the performance of the developed turbine device, which consists of 2 turbines in parallel. The objective was to understand the behavior of the fluid flow within the device and evaluate the impact of various design elements on the velocity and efficiency of the turbine. To initiate the simulation, the device was modeled, taking into account its geometrical features, including the presence of flaps at the inlet. The flaps were designed to direct the incoming airflows towards the turbines, increasing the fluid velocity at the turbine inlet and optimizing energy conversion. The device was placed in a computational domain, and appropriate boundary conditions were defined. The initial conditions for the simulation included an inlet velocity of air set at 15 meters per second, representing an ideal scenario. The sides of the device, except for the inlet side, were set to ambient pressure to simulate the surrounding environment accurately. During the simulation, the fluid flow within the device was analyzed and visualized through various parameters. One notable observation from the simulation was the formation of maximum velocity zones in between the turbines. This phenomenon can be attributed to the smaller area between the turbines, creating a Venturi effect. The Venturi effect results in an increase in fluid velocity, facilitating more efficient energy conversion. Based on simulation results, the maximum velocity achieved in between the turbines was approximately 20.479 meters per second. This indicates that the design and configuration of the device are successful in creating an optimal flow environment for the turbines, maximizing their performance. The clutch is a means to integrate 2 renewable energy generation sources that, despite utilizing completely different sources of energy, is rarely implemented in unison. Often, the solutions to maximizing the potential of one contradicts with the other, but with the clutch, it doesn't have to. Using sensors, the clutch is able to detect the weather and accordingly choose to either deploy or retract. Whether rain or shine, The clutch ensures that the hybrid renewable energy system is able to reach its maximum potential. Utilizing a simple structure design and rudimentary electronics, it aims to be a minimally invasive installation and inexpensive yet integral addition to any wind and solar hybrid system, improving the efficiency of the entire system with little complexity and investment. While renewable technology scales upwards into achieving greater efficiencies, the improvement in how well we integrate these state of the art technologies is how we get ahead into a future free of the fear of climate change.